In this part of our training, we'll focus on supercells, characteristics, and their visual clues. Supercells are highly organized storms that produce a high threat to life and property. They have strong updrafts and strong wind shear. These updrafts will rotate. A rotating updraft is called a mesocyclone, or meso for short. This only occurs in supercells. The rotation is caused by the wind shear in the atmosphere. Supercells can produce all types of severe weather. They can produce tornadoes, and they do have a higher potential for strong or violent tornadoes. They can produce high winds or wind damage in two different areas. They can occur with the front flank of the downdraft, which is the heavy rain and wind gusts on the leading edge of the storm, and with the rear flank of the downdraft, which is on the back of the storm where the tornadoes form. They can also produce large hail and heavy rain in the updraft, downdraft area. Hail can frequently be bigger than golf balls, and the heavy rain can be causing flash flooding as well. A rotating updraft, as we call a mesocyclone, is wind shear that causes a rolling motion. In this particular image, the rotating is occurring on a horizontal plane. A strong updraft starts pulling this rolling air upward. And eventually, it'll be on a vertical plane. The resulting is a rotating tilted updraft, or a mesocyclone. Here are two examples of supercells. The one on the left is called a classic supercell. The one on the right is called a high precipitation supercell, or HP for short. Both of these produce spiral bands and striations and updraft towers, and these are clues that the updraft is rotating. Look for a wall cloud with a supercell. This is a persistent lowering near the base. These are usually long-lived. The key is that they're rotating. An upward motion is often present as well. They may contain a tail cloud, which points toward the area with the heavy rain. In this particular example, the tail cloud is small, but it's pointing toward the left. Here are a few different examples of wall clouds. And in this visual loop of a wall cloud, this may be better to pick out some of the features. But in this area, you can see the rotation forming and developing as the loop goes on.